Hello, my name is Paul Gerber and I am a software developer on the IBM Streams platform team, and today I will be demonstrating an IBM Streams standalone deployment. For this video, I will cover deploying a Streams Kubernetes operator, creating a Streams instance, exposing the Streams console, submitting a Streams job through the console, and then deleting a Streams instance. Let's begin. For the Streams Kubernetes operator deployment, there are 4 main steps to perform. First, download, extract, and inspect the installation package. Second, set up an OpenShift project or Kubernetes namespace. Third, load the bundled Streams images to an image registry. And finally, apply the Streams Kubernetes operator manifest. Before beginning any of these steps, make sure you have an OpenShift or Kubernetes environment with cluster administration and an image registry available to use. Let's go to the command line for the first step. I've already downloaded the installation package ahead of time as a compressed tarball. First, we'll unpack the file using the tar command and ensure the installation package is extracted. Next, we'll take a look inside the package. Inside, you'll find several directories. The bin directory contains several helpful scripts for handling the Streams images and manipulating your OpenShift or Kubernetes environment. The charts contains Helm charts for users who wish to deploy Streams using Helm. The images directory contains a compressed archive with all the Streams images bundled together. The operators directory contains YAML files necessary to create and deploy the Kubernetes operators. And finally, the samples directory contains several files and directories that are great starting points for users. Inside, you'll find sample Kubernetes manifest files, templates, and more. The next major step is preparing an OpenShift or Kubernetes environment. Today, I'll be walking through an OpenShift environment, but a lot of the steps are the same for Kubernetes. Before I begin, it is important to note that you will need cluster administration access to perform the necessary setup. If you are unable to get the access yourself, ask your cluster administrator to perform the steps. The first thing to do is configure access to your environment. OpenShift users can do this using the OC login command. Kubernetes users will need to configure the kubeconfig path. Once configured, create a new project or namespace using the command line. Call the project something meaningful, like Streams Standalone, like I've done here. Next, run the apply_all_crds.sh script, which will apply the Streams custom resource definitions to your environment. Next, I'll walk through some OpenShift specific steps to enable the correct security context constraint, or SCC. First, we'll apply the provided SCC called IBMStreamsInstance.yaml under the samples directory. This SCC defines the necessary user ID range and permissions for the containers to work properly. Next, we'll apply the SCC to our project by running the OpenShift client command ocadm policy add SCC to group IBM Streams SCC system : service accounts : the project name. In this case, we'll use Streams Standalone. This command specifically applies the SCC to all service accounts in our Streams Standalone project, so we are free to create new service accounts with the policy. Lastly, we'll need to create a Docker registry secret if the image registry you plan to use requires credentials. To do this, we'll create a Kubernetes secret called myRegistryKey with my credentials. For the next step, we'll need to load the Streams images to an image registry so they can be accessible to the container orchestration environment. This step will require an image build system with Docker and be authenticated to the image registry. Before we begin, it is important to note that the user running the command has read-write access to the installation package. If not, users may have to perform the steps in the scripts manually. The first thing to do is run the load_streams_images.sh script under the bin directory. This will load the Streams image bundle into the local Docker daemon on the system. The bundle is several gigabytes in size, so the process may take several minutes. Next, run the tag streams_images.sh script. If not specified as arguments, the script will prompt for the image registry. Be sure to include any additional prefix if the images need to be put into an image namespace, and confirm the new image names. Note here that the script removes the old image names. Finally, run the push_streams_images.sh script to push the newly tagged images to the image registry. I've already pushed the images up once, so it goes quickly here, but generally this process can take several minutes depending on network speed. Now that the Streams images are in an accessible location, we are ready to deploy a Streams Kubernetes operator. Specifically, we will be deploying the Streams instance operator. Before we begin, it is important to note that the user running the command has read-write access to the installation package. If not, the operator may have errors when coming up. Before creating the operator deployment in our environment, we must first set up permissions for the operator through role-based access control objects. Run the apply instance rbac.sh script to create a service account, role, and role binding for the operator if they don't already exist. Next, we'll run the apply instance operator.sh script. The script is unaware of the image registry that we pushed our images to previously, so we'll need to specify the registry and any additional prefix. We'll also include the myRegistryKey pull secret we created when we set up the project so the image can successfully be pulled into the environment. Once the operator is deployed, we can check that it's running through the command line by executing a getpods command. Looks like we're all set. The next demonstration will be creating a Streams instance. Now that we have the Streams instance operator running, it can manage instance lifecycles. But we'll need to go through 4 more steps to create an instance. The first step is copying an IBM Streams instance manifest sample file. We'll copy the IBM Streams instance manifest sample file found under the samples/operators directory. The sample file is called IBMStreamsInstance-example.yaml, and I'll copy it to the root installation package and call it myinst.yaml. After we have a manifest file to work with, we will need to configure the manifest for the instance we want to create. Some things to consider are the name of the instance, whether to manually or dynamically provision persistent volumes, service types, and security. A Streams instance requires a security configuration, either through a Streams security service or through a lightweight directory access protocol server. Since we have not set up a security service, we'll be configuring our instance to use an existing LDAP system. Let's open up the myinst.yaml file and take a look inside. The first uncommented outlines show the API version and kind fields set to streams.ibm.com/v1 and IBM Streams instance in camel case. These values are needed to tell our environment what kind of object to create. Next, we'll move to the metadata.name field and change it to myinst. This will be the name of the instance when we create it. Next, we'll set the license value to accept since we accept the legal license for the product. The image.prefix field allows us to specify the image registry and an additional prefix where the Streams images can be found. We'll set this to the value we used when we published up the images to the registry. We'll also need to put myRegistryKey in the image.pullSecrets field. Next, we'll move to the instance section and allow dynamic provisioning of PVCs for the instance by specifying a storage class in the persistent storage class name field. If I already had a PVC available, I could specify it in the persistent volume claim field. After that, we'll move to the security section. As I mentioned earlier, we'll set up the instance to use LDAP. I'll populate the fields with the necessary values to make a user called Streams admin, the instance administrator, set up user lookup values, and the URL to the LDAP server. And finally, we'll save the file to finish our configuration changes. Be sure to check the Streams documentation for a full list of values. The next step is to apply our instance manifest to create the instance object in the OpenShift or Kubernetes environment. All we need to do here is use the OpenShift or Kubernetes command line client to use the apply command with -f followed by the manifest file, myinstance.yaml in this case. Once applied, an instance object is created in our environment. The last step is to monitor the instance installation status. It is important to inspect the instance object, any dynamically created PVCs, Kubernetes services, and pods. If any errors occur, consult the operator logs for the reason. Oftentimes it may be due to misspellings or invalid values in the manifest file. The first thing we'll do is a get IBM Streams instance command to list out the IBM Streams instances in the project. Next, we'll check the PVCs. It does look like myinst instance PVC was created using the storage class I provided earlier. Next, we'll check the Kubernetes services in the project. There are several of them prefixed with my_inst, so it looks like the operator is in the process of starting the instance up. We'll confirm that by running a get pods command, and we do see several pods in the process of coming up. To wait for the instance to be ready, I'll run a get IBMStreamsInstance command, followed by the instance name, with the -w flag to watch for any updates, and then a specialized -o option to pull out specific information from the my_inst object. It may take a bit for the instance to finish initializing. Eventually, a message should pop up saying the installation was successful, along with some helpful messages about what to do next. We'll do one last get pods command to confirm all the instance management services are running. Everything looks good, so the instance is ready for work. By default, a Streams instance does not expose the Streams console outside the OpenShift or Kubernetes environment. This demonstration will show how to expose the SWS instance service, which contains both the console and the REST API for the instance. Once exposed, Streams users will be able to access the console and REST API outside of the environment. Note here that there are many ways to expose a service externally, and that these steps are just one way to expose the service. Ask your cluster administrator for the best approach to use. As shown earlier, the list of instance services are all a cluster IP type. This type exposes the service on a cluster internal IP and makes the service only reachable from within the cluster. An easy way to expose the service is by a node port service type. The node port type exposes the service on each node's IP at a static port. You'll be able to contact the node port service from outside the cluster by requesting the node IP: the node port. To do this, we'll edit the instance manifest to change the service type field under the SWS section to node port and set the service external IPs field to an array of externally accessible IPs. Once that is configured, we'll reapply the updated instance manifest using the apply command. It is very important to note here that all pods in the instance will be restarted, so be sure to configure this before creating an instance or just after creating one. After being applied, we'll recheck the services in our environment by running a get services command. Make note that the SWS service has changed to a node port type, the external IP, and the port number after the colon for the node port to use. With the SWS service exposed, I'll now demonstrate how to access the console and submit a job using the console. We'll start by bringing up a web browser. For the URL, I'll specify HTTPS, the external IP for the SWS service, the node port, /stream/console. Because I configured the instance without proper certificates, the instance created self-signed certificates, so I'll accept the warning and progress. On the console, the intro page will display a login. Use the username and password for the administrator user. In my environment, I set the Streams admin user, so I'll log in as that. The console includes information about the Streams jobs, processing elements, operators, data streams, and more. To submit a job, I'll click the play button at the top of the console to submit a job. The page will show two options to submit a Streams application bundle. Today, I'll be uploading a bundle from my laptop, so I'll click Browse and navigate to my rate application bundle. Before clicking Submit, I'll click on Configure to edit my job deployment. First, I'll set the job name to sample job and then set a value for the required submission time parameter tuple size. Once that's done, I'll click Submit. The instance will upload my bundle to the container orchestrator environment and spin up container resources for the application. Looks like the job submission was successful and the job graph is updated with my Streams operators. Taking a look at the resources, it looks like a resource called app0 was created for my job. The last demonstration I'll walk through is deleting a Streams instance. Be warned that deleting an instance will stop and delete all running jobs, persisted data, and dynamically provisioned PVCs owned by the instance. So do take a moment to review that the instance is no longer needed or in use. To delete a Streams instance, you need to run a delete IBM Streams instance command with the name of the instance, my_inst in this case. When the command is executed, several cleanup processes will start, which may take several seconds to complete. Only when the cleanup processes are finished will the delete command return. And that's it. If you would like more details regarding any of these demonstrations, do do consult the Streams documentation for more information. Thanks for watching!